Hi, so today we'll be doing this physics problem, and we are given a block with mass m. It's pushed by a constant force F that makes an angle of theta with the horizontal as shown. The block is moving with constant velocity on a level surface. The coefficient of kinetic friction between the block and the surface is UK. What is the equation for the magnitude of F? So first of all, we'll draw our free body diagram. So we have the block, and then we have the weight of it. And then from the ground, we have the normal force. Then we have the applied force, which is F. And then we have the frictional force. And then the applied force can also be broken up into X and Y components. And then theta. So next what we'll do is our equations of equilibrium. So we'll start with sum of forces in Y, and that'll be 0 because it's not moving up or down. And so what we have is Fn in the positive Y direction. And then we have Fg in the negative Y direction. And then we have Fay in the negative Y direction. And so we know that Fay equals Fa sine theta. And then while we're here, we can also just write Fax equals Fa cosine theta. So subbing this in, we get 0 equals Fn minus, and then we know that Fg also equals mg. So minus mg minus Fa sine theta. So we know now that when we do the sum of forces in X, that we will have the frictional force, and then the equation for the frictional force is UK times the normal force. And so we'll solve this equation that we have up here for the normal force. So we get Fn equals mg plus Fa sine theta. So now we can do sum of forces in X, which will also be 0 because it's given in the problem statement that the block is moving with a constant velocity, so it's not accelerating in any direction. So with this, we can write that Fax minus the frictional force equals 0. So we already have our equations for what we want to sub in for Fax and Ff. So we can sub those in now. So we get 0 equals Fa cosine theta minus coefficient of kinetic friction times normal force. So then we also found what the normal force is by summing our forces in Y. So we have Fa cosine theta minus kinetic friction coefficient times mg plus Fa sine theta. And so now we can rewrite this. Fa cosine theta minus UK mg minus UK Fa sine theta. So now we can rewrite this. We can pull this UK mg to the other side. So UK mg equals, and then we can pull the Fa out because that's what we're looking for. So we have Fa times cosine theta minus UK sine theta. And then I'll move it over here. And this can be rewritten as Fa equals UK mg over cosine theta minus UK sine theta. So this is our answer, and I hope this helped.